Hello and welcome to Math 12 Compound Interest using the formula. So we have here the formula A equals P bracket 1 plus R over N to the power of NT. And the first thing is we're just going to do a quick run through of what each of those mean. So this of course is the amount after time, and I'm using some shorthand here. So that's your future value is the other way we discuss this one. P is your principal. That's your initial value of the investment or loan. R is your interest rate, and that, remember, is always in decimal. And that, you'll see it quite go out of hand quite quickly if you've got large enough numbers, if you forget to change it to the decimal format. I'm going to skip over here to T. We know this one as well from simple interest. That's time in years. And here we have the new one, the N. And you see it showing up here in two places. It affects both the interest and the time. N is quite simply the number of times per year the interest is compounded. So, for example, if we are talking about semi-annual compounding, then that means that twice a year we are compounding the interest, which means then that we have to cut in half the interest rate because we're going to compound it twice a year, and we double the number of years because we're compounding it twice per year. So N then is the number of times per year interest is compounded. That's our formula. Now let's put it into action. Coming over here, we have Yvonne, and she earned $4,300 in overtime on a carpentry job, which she's investing in a 10-year CSB at 3.8% interest. So looking at your information, $4,300, that's your principal. And she invested the money for 10 years. So our time is 10 years. Our interest rate is 3.8%, and it's compounded annually. So N in this case is simply 1, because we're only compounding it once per year. So that makes this quite a simple compounding problem. We don't have to really accommodate for multiple times a year, so we could ignore the N on this one. But I'm going to use the full formula with the N so that you are accustomed to seeing it. So here we've started on a clean screen, so you have all of the space to do the work and start plugging in those values that we collected from the problem. So the principal is 4,300 times 1, which is always in the formula, plus our interest rate, and remember it's in decimal, so we have to change that to 0.038, and my N we determined was 1 because we were only doing the annual compounding, and we put 1 up here again as well, and our 10 years. So we've plugged everything in, and now you can go to the calculator. I'll do one more step of simplification, and then the calculator takes over. 4,300 times 0.038 over 1 is still 0.038 plus 1, and our power 1 times 10 to the 10, and now grab your calculator. And the amount is $6,243.70. Remember, you're going to round to 2 decimal places because we're talking money here. So that's what the formula would look like if she was compounding annually. But I also want to show what it would look like if she was compounding semi-annually. So I'm going to change to the red pen, and we're going to now make n equals 2. Everything else is going to stay the same. We're going to find an investment for her 4,300 for 10 years at 3.8, but these are generous people who are compounding twice a year. Formula stays the same. And plugging it in. Same process. 4,300 for the principal, 1 plus 0.038 for the interest rate, but now our n is 2, and our n is 2 up here as well. Still the 10 years. And so now you can see that your number is going to change here inside the brackets. So this is going to be 1.019. So I've done the 2 steps. I've divided the 0.038 divided by 2 and added it to 1 at the same time. And my exponent now is 2 times 10, which is 20. Again, we're back to the calculator. And now, at semi-annually, she has earned $62,065.45. So she's earned a little bit more. She had earned $62,4370 in the annual compounding, and she's earned $62,65.45 in semi-annually compounding it. So about $19 more, not quite $20 more. So that's a benefit, not huge, but every cent that's in our pocket instead of the banks or corporations is what we're looking for. To follow through and just to watch it grow, if we were to look at this from the point of view of having done it quarterly, then I'll not go through the process again, but the amount came out to $62.76.56, and monthly she earns $62.84.05. So you can see that if you can get that same interest rate with more compounding periods, it's worthwhile. She starts seeing to get up there to almost $40 more if she could get the higher number of compounds per year while still at the 3.8%. And imagine if she had a bit more money. The more money, of course, that she's able to start off with, the more you're going to result in at the end. Compound interest using the formula. Good luck.